Math 13 students, we have the last bit of technical update for the material in Chapter 4. This is Section 4.4, Counting. And I'll remind people that when it comes to probability, usually there's some counting involved. How many times does something happen, divided by how many things happen altogether in whatever situation it is you're observing. Usually there's some sort of fraction like that involved. So come along with me. We'll take a look at the detail. Our calculator will be quite useful here. It has some built-in capability that we'll need to access. So watch the keystrokes and let's go. All right, section 4.4, counting. Here's some worked examples. A little bit of an outline first. We're going to go ahead and review some notions regarding order and arrangements. We're going to review the counting formulas involved. And as we make this little journey, we'll take a look at some appropriate examples. All right, so ways to count. There's a number of different ways to count up occurrences or arrangements, if you will. Really depends on the situation involved. And honestly, this is one of the things that makes probability a challenging topic for my students. It is very context dependent, vocabulary heavy, and there are some rather intimidating formulas involved, although honestly, your calculator has them already built in, so they're very easy to use. So let's see how we do this. There's 4 different ways to count up arrangements. It really depends on the situation. The basic rule is the multiplication rule. We'll follow that up with the factorial rule. Then we'll talk about permutations and combinations. The last 2 have some nice subtlety in them and a rather gnarly formula. You've seen the formula before. We'll talk about it when we get there. All right, the counting rule, multiplication counting rule. There's a sequence of events with a known number of choices for each event, then we can get the total number of arrangements by multiplying those choices together. For example, a restaurant offers 7 appetizers, 4 main courses, and 5 possible desserts. How many possible different meals are available to you? 7 times 4 times 5 gets you to 140. So it's really pretty straightforward, the multiplication counting rule. In this particular situation, at this particular restaurant, there are 140 different possible dining experiences that you might have if you go there. Now, let's talk about factorials. You got a bunch of items you like to arrange, something special on the shelf, awards, what have you. Well, if you have n unique items, we use the factorial formula to give us the number of arrangements. There's a formula involved, n factorial. Yes, that's the exclamation point, but here it's really a mathematical symbol. N factorial stands for, n means n times n minus 1 times n minus 2, all the way down to times 2 times 1. We also have a very special definition. 0 factorial equals 1. Essentially, we define the number of ways to arrange 0 objects as a single way. Kind of interesting when you think about it. Let's look at an example. My son has a wooden train with 7 distinctly different freight cars. How many ways can he put his train together? How many different ways might he build his railroad? This is a case of factorial. So if we take a look at our calculator, 7 times 6 times 5 times 4 times 3 times 2 times 1, hit enter. 5,040 different ways he might put his train together. Now, honestly, that's a little tedious. My calculator has the ability to work with that exclamation point directly. Notice, I'll type in the number 7. Then I've got a key over here that says math. I'll scroll over to the drop-down menu that is for probability. And then I'll take a look at number 4. Number 4 is the factorial operation. I'll hit enter, and I get that 5,040 possible arrangements. So, in factorial, 5,040. Well, it's no wonder he's late for his bath. He's very, very busy putting all his different trains together in all the various unique ways. Now, let's talk a little bit about subtlety. order and counting of arrangements here. Probabilities really depend on this number of arrangements or outcomes. Sometimes order matters. When order matters, the same items arranged differently count as unique outcomes. At other times, order does not matter. Some items, same items arranged differently would count as a single outcome if order is not important for the situation. Very simple example here. You have a mother that wants first a boy and then a girl, wants them in that order. Order matters to her. Maybe the dad just wants one of each, doesn't care which one comes first. For him, boy, girl, boy is all the same. He gets one of each. So there are real situations out there where order matters and order does not matter. You have to look at them all individually. Now, when order matters, we have what we call permutations. Permutations of items are the number of arrangements of different sequences of the same items. They're counted separately. Order matters here. See those three letters there, ABC, ACB, etc.? Well, those are all counted as separate, different arrangements if we're working with permutations, if order is important to the situation at hand. Now, there's an ugly looking little formula and some fancy notation that you've seen in your other presentations. So let's take a look at the example and I'll show you how the calculator will do the work. We have 4 scholarships of different sizes. Obviously, bigger is better when it comes to scholarships at a local community college. 12 students are going to apply, and we have to award those 4 scholarships. We're going to choose 4 out of the 12, and order is definitely important here. So, on my calculator, let's see, I have 12 students, so I'll plug that in first. I'll go back to the math key, scroll back over to probability. I'll select number 2, permutations, NPR, P for permutations. How many permutations? We're looking for, well, let's see, 4 out of those 12. I'll hit enter, and I'll get 11,880 possible ways we might award these 4 scholarships. The first little number, the subscript, that's the total number of items you're working with. The P stands for permutation. The second little subscript is the number of items you need to select from that big group of, in this case, 12. So there's lots of different ways to make the choice here. Now let's look at combinations. Combination of items are arrangements in which the different sequences of the same items count as a single arrangement. Order does not matter when we're working with combinations. You see those 3 letters there arranged differently? They count as one arrangement or one combination if order is not important to us in that situation. So we've got a teacher who divides a class of 15 students into groups of 4. We're going to have a discussion, probably about permutations and combinations. How many different ways might the teacher place the students into those groups? Here's a situation where order doesn't matter. Those 4 students are going to be in a group and they'll have some sort of discussion. So, how many students do we have? We have 15 students all together. So over here, I'll note we've got 15 students. Back to math. Back to probability. This time I'll scroll down using my arrow key. NCR, the number of combinations. How many items are we choosing? We're choosing 4. And then I'll hit enter. And I get 1,365 possible ways I might put my groups together in this situation. This is something teachers think about, by the way. So 1,365. Again, the little tiny number in front is the number of items you're choosing from, the pool, so to speak. The second little number is the number of items you're actually choosing from that larger pool. So, as I would say, if we're having discussions, stay on topic. Thank you. So, what have we done here? I've shown you some examples where we've looked at order, where we've looked at counting formulas, and we've reviewed the keystrokes involved. Your calculator is really quite the help here. You really want your calculator to be able to do these calculations. I'll remind you that they're shared all together under the math key. Let me just scroll through that one more time. Over here to probability, I have permutation, combination, and factorial operations. So I'll use those quite frequently as I work my way through this material. So that brings me to the end of the final technical update for the material in chapter 4. Let me stop sharing and remind you that you really do need to practice this stuff. The keystrokes are really important. The only way you're going to be able to know how to get a hold of the keystrokes at the right time is to practice them. So take a look at those homework problems. They're very word heavy. Reach out to me either during our office hours or in our discussion forum. Thank you and goodbye.